Welcome back. This is our fourth video of today. It's called non-decreasing array. So our input is a array. We're given an array of numbers with n integers, and our task is to determine whether it could become non-decreasing or just as increasing by modifying at most one element. We define an array is non-decreasing if the later element has to be greater or equal than the one before, holding for every zero-based element. For example, if we're given 4, 2, 3, we can modify this 4 to 1, then it will become a non-decreasing array. Let's look at another example. If we have like 4, 2, 1, so this doesn't hold. We can either change 4 to a smaller element or change 2 to a larger element. But then again, even after we made that modification, the whole array is still not non-decreasing. So what we can do is we first find the first violation, make proper modification, and then do a second traversal and see if there is any violation. Cool. So at the end, I'll just return true. So first, let's try our let's analysis some corner cases is smaller than 1, then I will just return true because I don't even need to worry about it. And then for my int equals to 1, smaller than my nums size, I++. If there's a violation, which means if my nums I is actually smaller than my nums I minus 1, then I need to modify my nums I or my nums I minus 1, right? So like which one to modify? So for example here, so my 2 is smaller than this. Should I modify 2 or should I modify this 4? Like my 1 is smaller than this. So I can I need to compare with my nums I with I minus 2. If my nums I is even smaller than the one that goes previously, for example, if I'm having like 1, 3, like 2, 3, 1, then I need to modify my I into this. So what I can do is if my I is greater or equal than 0 and my nums I is smaller, then I actually need to change my I to I minus 1. Else, I just change my I minus 1 to nums I, right? If like I can change this 4 to 2. Okay, cool. So after this, I again look through my array. If I found a violation, I'll just return false because my 1 I'll just return false. Otherwise, I'll just return true. Let me run the code. It seems to be working. Try to submit it. No, it says to expected. It should be false, but I was returning true. Okay. Let me try to debug it. Console, if I do 4 to 1, I was actually making, let me try to do this, debug. At first, I started from 1, like 2, I found it's smaller than this. so it's not true. So I will just modify my 4 into 2, right? Okay, 2 to 1. Oh, and then I should do break. Yes. Okay, then I just do, after this if, after my modification, I should do break. Because I cannot like change more than once. Cool, now it passes. The reason is if I do not have a break here, then after the first modification, I'm still going to traverse the array, and whenever there is a violation, I'm making corresponding modifications. So that's violate that I only have at most one element per base. Cool. That's about this non-decreasing array. I would say it's still like a greedy-ish algorithm, but it definitely is another thinking pattern. Like if you only have one modification and you have some violation, you just do the modification and you check whether there's another violation to that. And lastly, let me just quickly write down my time complexity. I did 2L traversal, oops, so it's going to be n, and my space complexity is going to be constant. Complexity is going to be constant, right? Let me just try to see the answer again. Cool, that's pretty much it. I wonder why it's so slow. Greedy algorithm, yeah, like seems about right. We iterate until we find the end of the array, find violation, sorted, then we return true. Otherwise, we found a violation. Oh, should I like? Should I like have a boolean, and then? Okay, I have a boolean. I would say modified equals to false. If I found one, I will do modified equals to true. But if I didn't find one, if I would say, okay, if modified, if I didn't even need to modify, then I just return true. This way it can be optimized a little bit. Not really. Anyways, yeah. Okay, yeah, it's probably due to the test cases, but either ways, that's it for this video. I hope you guys enjoyed it, and I will see you next time.